Hello, everyone, and I want to thank you so much also for inviting us to this very open intellectual environment where everybody can speak their mind. I'm very happy to be here to be able to talk about things that I care a lot about, whole brain emulation. So my name is Christian, and I'm the co-founder of a whole brain emulation startup. We have 2 animal labs in the UK, and we're currently testing the feasibility of being able to construct a scalable, dynamical whole brain emulator of a mouse. And Katlin, my co-founder, will be speaking a little bit more about that later today. Also, it's very nice to see a lot of familiar faces here as well. We'll be speaking a lot more about that later. But first, I want to talk to you about whole brain emulation and personal identity, how evolution and physics maybe informs our sense of self and how we think about ourselves. So, as some of you probably know in this room already, whole brain emulation involves the emulation of the functional properties of a brain on a different substrate. And when you discuss whole brain emulation with friends, with colleagues, with anyone, maybe some of you in the audience have also experienced this, you reach a kind of a local minimum of conversation, in any conversation related to this, where you have to talk about how you conceptualize your personal identity. And depending on your answer of how you think about identity, how you view various different protocols towards getting to whole brain emulation, a destructive scan, a gradual process, all the different various protocols will drastically change depending on how you think about identity and also how you view whole brain emulation itself. So that's why I want to talk a little bit about how we form a way of thinking about ourselves. And also because to better defend ourselves, I think it fundamentally helps to understand what we are and what is our capacity to change ourselves to better defend ourselves. So what is personal identity in the first place? Well, in some fields, they've given it a formal definition. Identity is the conditions that underlie the existence of a system. And in some fields like information theory, statistical physics, and active inference, fields with considerable overlap with whole brain emulation and also each other, identity is often considered isomorphic to the priors of the system, where the priors of the system are what shape and inform the generative model that then powers the actions of that system. But when we talk about identity, if I was to ask anybody here, what are you, who are you, you're not going to answer, I'm the conditions that underlie the existence of my system. You know, we're going to be talking about it in psychological folk terms, much like actually philosophers do talk about identity. And philosophers have had some theories. So you have various here, the ego theory, a person's identity is their soul or non-physical mind, and this can also survive the death of the body. The psychological continuity theory, first articulated by John Locke, which is your ability to reflect on your memories and yourself, what happened to you previously. Kurzweil then generalized this into, in more general, your psychological configuration. Materialism, you are the matter that you're made out of, so if somebody was to swap your brainstem there with another one, too bad, you've lost a part of yourself. The no-self view, Nietzsche, the I is a grammatical fiction. Hume were composed of, we can experience the self, but we're not a clear whole. And various other people that have talked about the no-self view, Buddha, Derek Parfit, there is no survival because there was never any person to start with. And what I want you to take from this is that philosophers have had theories, but actually a lot of these theories have remained quite stagnant in the face of new neuroscientific knowledge. They've not really updated themselves. Also, some of them contradict each other, and they overlap. We have a few modern innovations that talk about a more transformalist identity that can embrace change. And also, I was very inspired by Puya's talk earlier about the soul-bound token paradigm and what you talked about. This is actually one of the ways of viewing identity that can be quantified in the future and can actually be applied in the whole brain emulation potential future that we might have. But identity is strange, and neuroscience is what separates the map from the territory in terms of thinking about identity. We now know a lot of strange things about the self. So for example, one example is patients that have a severed corpus callosum. This is usually severed because of severe epilepsy historically. You'll have the different hemispheres have different preferences. So one side will be reaching out for coffee, the other will literally stop it. The rationalist movement is also deeply familiar with the flawed mental heuristics that people live by and experience. One example is that the narratives that we actually spin about our lives are frequently false and don't live up to the actual lived experience. And much, much more things have stimulated recent thought about how we view our identities. But thinking about future technology that doesn't even exist yet has also stimulated a lot of thought in the philosophical world about identity. And one very influential example was by Dennett, and it was an essay he published called Where Am I? And in this thought experiment that he lays out, he is recruited on a secret mission by NASA because a bomber plane has flown over Houston and accidentally dropped a nuclear warhead into a ravine. So these neat scientists have a very brilliant idea to protect him from radiation. They offer to remove his brain, place it in a vat, and connect it to his body via electric radio waves, by radio. And then it agrees and says, okay, sure, let's go. And then he asks this very leading question. He says, calls the brain Yorick and the body Fortinbras, and he asks, where is the real I? And he asks the leading question, making it mutually exclusive from the get-go. But I think that the reasons why human beings we find this question strange and the answer isn't clear. The reason why this is because of habituation, evolution, and biophysics. And I think that the reason why people have trouble thinking about whole brain emulation and the various protocols for achieving it concern a lot of the same reasons. So why is the story strange? The story is strange because we're very used to our parts being close together. Since abiogenesis, our body parts have been linked together and we have to communicate with our various appendages and limbs via biological signals. And more crucially, the molecular machines that actually allow us, that enable these electrical signals, had to be discovered by a very, very dumb, gradual kind of gradient descent search towards the features. And these, when you're looking for a feature like an eye or an ear, you need a constant affirmation that this feature is actually improving your inclusive fitness in the world of natural evolution. So when you have features that do give constant affirmation, like sensing ears or eyes, then multiple species evolve these features. But when making biological signals travel as electromagnetic waves over long distances, have no gradual reward. You put a lot of pieces together and then you have this step change. And humans can create non-local features. Natural evolution cannot. And indeed, we did that. We already have tech from the Where I Am story that allow patients to communicate to their limbs spatially from a long distance. And these patients will report that their arm is themselves just as much as any other body part, and they will experience it to be so. This is possible because our brains think slowly. Our brain thinks much closer to the speed of sound than the speed of light, so we perceive it as instantaneous. So to answer this story from a transhumanist lens, we are in both places in Daniel Dennett's story. However, both in the story and in real life, we still have biological brains, hence the slowness paired with the speed. If we had a brain that was thinking at the speed of light, then the arm would actually seem far away. And this gets to one of my main points, which is that the fact that our brains are slow have AI safety implications today. Biological humans are slow across all domains. This paper is amazing. I highly recommend it. They validate it across many different domains, from coding, Rubik's Cube solving. We really think at 10 bits per second, or 10 to 15 bits. Whereas when you're running on light, you can think a lot faster. A single H100 tensor core can think at 10 quadrillion bits per second. And the way that these things are thinking hasn't been optimized yet, but they will. And this is also, I want to really point this out, this is a fundamental wetware limitation. I know we have some people that are working in the BCI space here, and that is amazing, but BCI does not solve this limited thinking speed that we have due to having biological brains. And also, of course, perception, the richness of human life, is also limited by natural evolution. Natural evolution is just as indifferent to human values and wants as misaligned AI, and there might be potential to experience a lot more things potentially. So why does this matter? Why did I choose to talk to you about these examples? I think that if we become more understanding of the fact that technology can change our perception of ourselves and what we consider to be ourselves, we may cease finding whole brain emulation radically different from what we consider ourselves today. We might see it as more of a possibility to ourselves, make ourselves more comfortable with the idea, and begin to seriously consider the possibilities that whole brain emulation may bring in terms of defensive accelerationism. And I do believe that whole brain emulation is the most important technology to put our weight behind today. There's a lot of people working on amazing things in this room, but I do think that whole brain emulation is the most important. So how does this work? How does this relate to Netho Labs? we're trying to advance theory, and we welcome collaborators to work on this problem. How does whole brain emulation impact the psyche as a bystander and as a participant, as well as actual X risks that might emerge from whole brain emulation itself? We also have several educational programs and welcome collaborators there. What is whole brain emulation, and how can whole brain emulation aid AI safety? We might have a workshop in the near future with some AI safety organizations related to that question and trying to advance theoretically how does whole brain emulation and AI safety fit together. We also are going to do, started early days of doing interpretability research of our own systems, following on from the recommendations made in the NeuroAI for AI safety report published, I think, last year. And ultimately, though, what we want to actually be able to do is to engineer human whole brain emulation so that human beings can have agency in a culture series world. That would be a positive outcome, but also to be able to act as a competent defender in a world far worse that doesn't look like the culture series. Thank you very much for listening. And I'll bring the mic around if anybody has some questions as well. Great. Great, Bernd.
We do have a Q&A, though, a panel for everyone in
Yeah,
a
but
row.
he was asking if somebody has a question, and I have questions. So, my question is a bit of a primer. So we had a cognitive sovereignty week here, and we talked about certain manipulation hijack technologies, like claiming stuff and virtue signaling, like calling something rationality or giving kudos to high-profile people that is well known, that are very well respected in here, and also maybe even preemptively belittling other projects like BCI. Nah, never will solve it. Okay, all cool. Just so that you know, the audience was primed, and we actually learned to point out and identify people that abuse such things and the communication bandwidth for their own needs. And I want to ask you, are you a profit-oriented company or not?
That's a great question. So we haven't taken any for-profit funds yet, but I'm going to answer your question. I'm going to answer your question. But we've decided to become a for-profit company, and that's what we're planning to do. We thought long and hard about this, and we've applied to many organizations. We wanted to be a non-profit, but we weren't able to find the funding that we think we need to be able to have the impact that we want. And I'm very happy to also discuss this further if people have more ideas about alternative routes. One thing that I discussed with people in London recently is the potential of doing a split organization. I don't think that our organization at this point have the capacity to do a non-profit and a for-profit, and that this would overcomplicate things, in my view, because we're still so mission-oriented as individuals. But I'm very open to hearing your ideas, if you have any idea, Bernd, anyone, about how that might be done. Any other questions?
It's just a brief question. So what would be the difference between emulation and simulation? Like you say whole brain emulation and whole brain simulation.
Yeah, this is a question. I mean, fundamentally, people don't know. In some of the literature, you say that simulation is something that doesn't feel, right? Isn't experiencing something, whereas an emulation is something that is feeling something. In terms of scale separation or the level of resolution of these things, we don't know what is required. From a functionalist perspective, as a la Daniel Dennett, I'm not saying that this is necessarily the view that NetherLabs takes, but according to Daniel Dennett, in the functionalist view, like if you have a functional emulation that quacks like a duck, talks like a duck, most likely the most efficient way to represent that would necessarily have experiences similar to human beings. But it's a problem that hasn't been solved. And within the field, there's a lot of kind of debates about what is emulation, what is simulation. And emulation is the term that I think used by people that want the thing to have experience eventually, whereas simulation is more kind of a detached scientific term that's used, even when you may be talking about the same thing. I hope that answers your question, but happy to discuss it more later too.
Thank you, Christian.